All right, welcome everybody. Let's get started. Wait for the monitor to warm up here. We'll go over a couple of announcements. Your next homework assignment is due on Friday, and that includes some of the information that we went over in class on Monday, and then also we're going to be doing some additional benefit cost stuff today in class. And then the next thing that's on your plate after that would be the following week, where on Friday the 22nd you both have homework number 11 due, and we have an exam scheduled for that day in class. I've received a couple of requests from students who want to start their spring break early, who didn't want to take the exam that day. None of them were university excused absences, but yet I'm inclined to accommodate them nonetheless. So I thought it wouldn't be fair to give the special opportunity to just a handful of students, so I want to open it more broadly that if you don't want to take the exam in class this day, there is one other option. If you'd like to take the exam early, you could do so on Thursday, so that's just the day before, from 2:30 to 3:30 p.m. And I apologize, I don't have a whole cornucopia of times available for you. That's really the only single hour I have next week that I would be able to administer a second exam. So I know you may need some time to think about it, but just so I can get a sense for maybe which room I need to reserve in case there are a lot of students who'd want to take this early option, how many of you would be interested in taking the exam on Thursday instead of Friday? All right. So there are definitely a few. The location is to be decided. I'm going to talk a little bit more about what's included on the exam, but I just did want to see if there would be broad appeal from more people who want to start their vacation early. Yeah?
Are we going to have a full hour on the exam if we take it on Friday as well?
You'll have 50 minutes. So should I say 3:20? Would that make you feel better? Okay. Yeah. No, they're not getting an hour. They're getting the same time as you. But it won't be the same exam. So if you're worried about parallelism, they won't be the same questions. I'll do my best to try and make them the same level of difficulty. Any other questions? All right. So included on the exam, there are going to be concept questions, which are short answer type questions. And when you're solving those concept questions, you're not going to have access to the page of notes that I'll allow you to bring and use for the second part of the exam. So the exam has two parts. Part one is concept questions, where it's just you and your pencil. And then the second part of the exam is problem solving related. So on the problem solving type questions, not only will you be able to use the equation packet that I provide, which includes the standard time value formulas and table lookup factors, but you can also bring a page of your own equations and notes. So what you should do is you should review the homework assignments and you should review the in-class exercises that we've done since the first midterm exam, and collect any reminders you need or any special equations that would help you to solve the types of problems that you've solved so far. Also included and new on Exam 2 are computer-based questions. You didn't have access to any Microsoft Excel on the first exam, but I will have a question that would be best solved by Excel on the second exam. When you do that, you have to start with a blank workbook. So I'm going to position myself actually in the back of the classroom so I can keep an idea on people's computer screens, and I'll be looking into the file properties and all that sort of thing. But the take-home message is that you have to start with a blank workbook, and you can have maybe like a procedure written out on your page of notes or reminders of what the column headings can be, but you can't just start with a previous homework or previous in-class exercise on the exam. You have to begin from scratch on the exam for the Excel type questions. So that's what I have in mind for the exam 2. I can't answer things like how many questions will there be because I haven't assembled the exams yet. But are there general questions on the coverage or anything else? Yeah? Anything you want. You can include formulas. Maybe you want to put in a procedure that reminds you how to do a certain analysis. You could write down decision criteria, definitions of things. Just keep in mind that that page of notes you can only use on the problem solving. You can't use it for the concept questions. Are there other questions about the exam? All right. So that will be a week from tomorrow if you're taking the early option, a week from Friday if you're going to be doing it in class. All right, so we did incremental analysis already. Incremental analysis for the rate of return, what we were doing is we were basically answering the question, is the additional investment amount justified? We can do the same sort of analysis in projects that aren't profitable if we're analyzing them on the benefit-cost approach. And so both of these pictures, all three of these pictures represent different means of flood control. The photo on the far left is showing a flood wall, and that's the kind of flood protection that we have here in Huntington. There's a flood wall that runs around the perimeter of the city. And they're really expensive to build initially, but they provide a high degree of protection. Another approach to flood proofing is to elevate the property that's valuable so that it's not susceptible to where the water is likely to be. So you can see that this house has been lifted. Now hopefully this isn't the permanent solution because it doesn't look like the sort. I wouldn't want to get in that house right now. It looks kind of rickety and unstable. It's probably just during construction they're lifting it with these. But if you've ever been down to Florida, like around the Everglades or on the coast, you maybe have seen there are residential structures that are really elevated. In fact, there's one a little bit like this here in West Virginia. If you're driving along Route 2, on the left side of the river, there's like a tiny house that's really big. I think it's around like what's that called? Green Bottom? That area where people go duck hunting? So there's an elevated tiny home where what they've tried to do is just essentially keep out of where the water's likely to be. So that's another approach, maybe less expensive than building a flood wall around the entire perimeter. Another approach to flood control is gigantic pumps. They have those in New Orleans so that when a hurricane comes through or wind-driven waves are raising the water levels that surround that city, which is entirely below sea level, then they have enough pumps to lift the water up and out away from the city center. So what incremental analysis can be used is to evaluate projects like these that aren't going to generate a rate of return. Huntington's flood wall was a cost alternative, and although it made the city real estate more valuable and it's prevented the damage over the years, people don't directly pay a fee, and it wasn't a profitable enterprise. So incremental analysis, remember, what we're doing is we're trying to compare the differences between options. And it may be that all three of these options, maybe all of them have a benefit cost that's greater than one. So it could be that all of them are acceptable. Benefit cost is just initial screening, though. You can't use benefit cost analysis to identify the best option. So there's a kind of a similarity there. Remember that when we were saying IRR is good for initial screening, but IRR won't tell you which option is best. IRR just gives you a thumbs up or a thumbs down as far as the acceptability. Well, benefit cost analysis is the same way. The project that has the highest B to C ratio isn't necessarily the project that you should undertake. And we'll talk about why that is. Remember, here's the formula for benefit cost, and this is according to the conventional criteria. In the case of modified, it's just slightly different, where the maintenance and operation costs move up to the numerator and the benefits are reduced by the amount of the maintenance and operation costs. So in incremental analysis, what we're doing is we're looking at the difference in initial cost, the difference in maintenance and operation, the difference in the benefits between alternatives, the difference in disbenefits between alternatives. So in the case of pumps, they're going to be very noisy compared to a flood wall, which is silent. And so disbenefits, remember, are those factors that affect people in a negative way. It can be environmental factors, societal factors, noise pollution, visual pollution, delay, inconvenience. And so the noise of pumps compared to the solitude of a flood wall could be wrapped up into the incremental disbenefits. And so basically what we do in incremental analysis is change this equation and use delta B, delta D, delta C sub I, delta C, maintenance and operation. So we're going to compare the differences. Just a moment ago, I told you that you can't pick the option that has the highest B to C. Like B to C by itself is good for screening, but it doesn't identify the option that's the most beneficial. Do you remember why that similar rule was applicable for internal rate of return? You know, why was it that the one with the highest IRR isn't always the best alternative? Because the reason why that similar rule applies here is for similar reasons. So why is it that some projects that have a lower internal rate of return are overall, they're better options than the projects that have a higher internal rate of return? Yeah. Okay. That's how we knew that one option was better than the other. So you're right. That's the indicator, but it's not the reason. So the indicator that one of the options is better than the other was that the present worth of the option. So just to make it a little more concrete, I think we had, let's just say for illustration, there's option A and option B. Now the IRR of option A is maybe 13%, while the IRR of option B is 15%. But then when we found the present worth, what he's remembering is the rule you can always trust is the one that has the higher present worth. And so maybe the present worth of option A was $15,000, but the present worth of option B was only $14,000. So what was it about option A that even though the IRR is lower, gives us a higher present worth?
Option A had an initial cost that was higher, but you got more back each year.
Exactly.
Increment.
Very good. So what he's remembering is what it all came down to is the original investment amount. Option A was more expensive, and so the idea was it's better to earn 13% return on a big investment than it is to earn 15% on a small investment. So the rule was, when you're comparing two options, one rule is always pick the one with the highest present worth. But now think about the marginal dollar, like the incremental spending. So in choosing between the more expensive option and the less expensive option, the rule is always spend that additional dollar when you get more than $1 back. So, in comparing option A and option B, what we said to ourselves was we should choose option A if we're going to earn more than the MAR. And so maybe the MAR was 10%. And so if you can earn 13%, but your MAR is 10, then you could keep spending the incremental additional dollar. So here in incremental benefit cost analysis, the same rule applies. So that rule is going to be keep spending as long as you get more than $1 in benefits for each dollar in cost. So in other words, that means, so if you're comparing two options and one of them's more expensive, you should go for the more expensive one if it's going to cost a little more, but you get a lot back. You get more than $1 in benefit for each additional dollar in cost. So that's kind of at the heart of the method we're going to learn today. And I've created a template file just to speed things up a little bit so you don't spend too much time like formatting column widths and bolding cells and that sort of thing, just to speed along the analysis. But here's the procedure that we're going to follow. We're going to use this modified B to C equation where what we've done is just substituted in the difference for each of the 4 factors. And the rule that we're going to apply is that when the incremental benefit cost ratio is greater than 1, then you should choose the more expensive alternative. And the book describes that more expensive alternative that we've now selected as the defender. It's like the best option until you compare it to the next most expensive option. And I think I might have used that same terminology when we were doing the incremental analysis before. You remember when we had the Atlas, the Caterpillar, Komatsu, those different trucks we were comparing, there was always like the current champion, and then there was the challenger that was a little more expensive, and we were asking ourselves, is it worth spending that additional amount? So the rule that when you've got the showdown between 2 options, the rule is if the incremental benefits are greater than the incremental costs, then choose the more expensive option. But if the incremental benefits are less than the incremental costs, then that ratio is going to be less than 1. And so what it tells you is that the more expensive alternative isn't justified. So then the cheaper alternative of the 2 that you're comparing remains the preferred alternative. Okay, so does that make sense to everyone that if you can get $1.50 in benefits for $1 of cost, you should definitely pay that $1 of cost. So you keep going for more and more benefits. You don't just go for the option that has the highest B to C ratio. You want to maximize the overall benefits. Here, your goal was maximize profit. So in the for-profit comparison, the goal, maximize profit. But today, since we're not working on profitable projects, we're working on projects that benefit society. So our goal changes a little bit. The goal is maximize benefit. All right. Here is a preview of the in-class exercise that I'm handing out. If you go on to MU Online, at the bottom of our class page is a template file. It's just an Excel spreadsheet that has all the values blanked out, but it does include like column width formatting and that sort of thing. So let me show you where you can find that. If you log on to our MU Online Engineering 222, at the bottom of the list is Incremental B2C Analysis Student Start File. So click on that, download it, and open it up. Thanks. Okay. So the options that we're comparing here, there are 4 of them, option A, B, C, D. And what we want to do is try and find out which of these options is the most beneficial. You know, how are we going to maximize the benefit? And these are all flood control options. And you'll notice that there are some costs, initial costs and maintenance and operation costs, 3 different kinds of benefits that you're going to have to combine together, and then there are disbenefits on an annual basis, and we don't know what they are, but they've gone through the process of trying to monetize each of those disadvantages. So in the template file, what I guide you through is the process, first of all, calculating the present worth. So this field in the blank spreadsheet is where you're going to do part A, and then part B is going to be in where it's got conventional B2C analysis. And what you'll note is the one that has the best B2C ratio isn't necessarily going to be the option that we end up selecting when the incremental analysis is applied. Okay, so I'm going to pause and give you some time to start working on that. If you don't have a computer today, then I'd suggest you cozy up to someone who does so you can at least watch them work through the activity. So I think a lot of you have already picked up on the fact that we're using the PV function a little bit differently than we usually do, because usually when we use the PV function, we're just moving a single amount back to the present. But here, this 52,000, there's multiples of that. That's happening 75 times. So when I refer to that amount, I put it not in the FV field, but I put it in the payment field, so PMT. So in other words, you're not going to put in that double comma that you usually use when we're doing the present value just for individual amounts row by row. What I'm telling this is I want there to be 75 amounts of 52,000. So take 75 of those to the present, and then the present value is going to be 855,000. Then we'll do the same thing with the benefits as well. So it's equals PV. Use the interest rate that's known for 75 years. And then what do we put as the payment? It's going to be the minus of the sum of these three things, because they're all benefits together. Let me make a comment that I hope will help you to avoid a frequently made mistake. You know, I sometimes try and tell you what students, the mistakes I see semester after semester. You don't know at the beginning what all of the matchups are going to be. You only know one matchup at a time, so you can't do the next matchup until you see who wins the first one. So the first comparison is B versus A. We know that because it's the cheapest and the next most expensive one. So I can say the first comparison is B versus A, but I can't yet start filling in the equations or anything else in the rows below it until I find out what was the result of this analysis, the first one. You know, is B going to be the winner or is A the winner? Because matchup number 2 depends on which alternative is superior in that first analysis. So I'm going to go through and show you what is the B versus A, but don't fill in all of the formulas because these stay blank until we know the interpretation of the first comparison. Yep. It's just to see if all the options are acceptable. This in-class exercise is illustrating that you can use the B to C analysis to identify whether a project is acceptable, and all 4 options are acceptable because all of them have a B to C greater than 1. So any one of these is going to be good for the community because you're getting more advantages than the dollar cost of the project. But we don't want to fall into the trap of just assuming that the highest B to C is the best project, because what we do through the incremental analysis is for each option we keep asking, so how much improvement or how much return are you getting for the added cost? So in B versus A, it costs about $780,000 extra, and there are incremental costs on an annual basis as well. But if you look, the benefits are huge. and the disbenefits are lower. So that negative value means that you have fewer disbenefits. So that helps things out as well. So there's a huge return. This 2.75 has a physical interpretation. What that means is that when you choose option B instead of option A, each additional dollar in cost gets $2.57 of benefit. So that's a great bargain. If you can spend $1 and get $2.57 back. But when you do that same analysis comparing C to B, you'd find that you only get 96 cents of benefit back for each dollar of cost. And so option C doesn't look good when our previous alternative was option B. But then we just want to compare D and B. Now we don't do D versus C because C has already been rejected. So that's why the final comparison is D versus B, is because we're choosing the last option that was a yes. So the most expensive option that's remaining versus the most recent yes, so D versus B, shows that we get $1.12 in benefit for each $1 in cost. So since that ratio is greater than 1, the decision criteria tells us keep spending as long as you get more than $1 in benefit for each dollar in cost. So each dollar of cost is getting us $1.12 in benefit, so we should spend extra for option D instead of option B. The last question asks, so let's say that we have some interest rate issues. What if you can't get 6% for your borrowing costs? What if your borrowing costs are higher than expected and they go up? So let's just play around with at what point are none of these options acceptable anymore? So 7%, we could still be okay. 8%, we're still okay. What about 10%? Still fine. 14%, we only have one option remaining, but how long is it acceptable? What if it's 15%? It's no longer acceptable. So somewhere between 14 and 15%, and I think what we find is that it's 14.5% is right the razor's edge. So if your borrowing costs exceed 14.5%, then none of these options would be okay. All right, that's all the time we have for today. Just remember that your next homework assignment related to benefit cost is due on Friday. Like I've said before, you're never going to know this material better than you do now when you've just finished the in-class exercise, so I'd encourage you to get an early start on that. I'll see you Friday.